Alright, hey everyone. Welcome to my third week of streaming random C++ stuff that I think is cool. This week going to be doing a few things. WinUI3, which is a kind of new modern way of doing UIs in Windows. And there's the opportunity to target other platforms as well. I'm going to talk about C++ WinRT, which is the C++ language projections for the Windows runtime. Coroutines, C++20 coroutines, and how you can apply them to GUI development. And also some FFmpeg nonsense. I played around with the Ffmpeg Api, and now I hate it, but I did it, so you all get to suffer and see the horrors that lie within. The basic idea is that I built this little application which you can give a video and it will take a bunch of screenshots of the video, and you can retake them and you can zoom in and out and you can save them off to disk. Hey card captor. And so yeah, I'm gonna show some of that and re-implement bits and pieces of it. Hey Helios. So should be able to see Visual Studio now. I'll go ahead and talk about Project Reunion. So Project Reunion is a Microsoft thing which the idea is bringing together a bunch of modern Windows development and making it better, making it more accessible. And it involves a bunch of things like WinUI3, which is what I'll be using today. It has text rendering, localization, there's some resource management stuff, and one of the other new things is this thing called WebView 2, which lets you essentially embed some web content inside a desktop application or something like that. It uses the Chromium engine. So that's kind of cool. This actually just went out a few days ago. When I planned to do this stream, I didn't realize that this was properly releasing. So like you can go and have a look at there's an announcement blog post on the Windows blog, which goes into some details about it. Says what Project Unification is, what's involved, like I said, the WebView 2 control, WinUI3, MRT core is that resource manager, dwrite core is the successor to direct write, which is for font rendering, and a bunch of other stuff. So you can go away and read this. Another cool thing that I didn't realize was there's this thing called Uno platform, which lets you actually use WinUI3 on like mobile platforms like Android. That's kind of cool. I haven't played around with it, but it's interesting it exists. But so WinUI3 is now in, it was in preview for a while. Now that Project Unification 0.5 is out, WinUI3 is ready for using, we think. It's not all there yet, like there's some things which are still unsupported, but it's really getting there. So like if you go to the GitHub page, you can see the roadmap here. It tells you a bit about WinUI. The basic idea is that, so previously, if you wanted to write desktop applications for Windows which used the kind of Windows look, and it was the modern Windows look, then you would have to do something like either target the Universal Windows platform or use this thing called XAML islands, which are weird. And it's kind of a pain. If you have like a native Win32 application, you'd have to jump through some hoops to get a kind of modern Windows style UI. Whereas now, WinUI3 supports Win32 applications, which is nice. It doesn't yet support UWP applications for C++. I think that's on the roadmap. Yeah, moving to XAML Island. Another thing to note is that I am in a completely different team from the folks who do WinUI and Project Reunification and all of this stuff. So my view on all of this is very much from the outside. Like, I wrote this demo application just using the documentation on the website. I didn't go internally with any of this stuff. Thanks to the follow bad ukulele cover. So I'm coming at this from like a similar position to most of you, in that also, like, I haven't really done much Windows GUI stuff. Almost all of my my production experiences in Linux systems. So like dealing with COM APIs and things like that is all completely new to me. But I'll go ahead and show you what I had. So this is what we're going to start with today. It's going to be like a framework of an application which I built up, and we're going to fill in some important blanks. So basically, when you get started with with WinUI, you can generate a template. I built a bunch of stuff on top of this to get my shell of an application here. So like I said, the idea is I want to be able to click open video. I want to be able to select a video file from my hard drive, and then that should space out a bunch of screenshots, which will display along here. I can opt to retake some of them if I don't like them, and then I can hit save to save those out to disk. So that's what I want to build, thanks to the follow cadence. So I built all of this before. I'm just kind of walking through some of the more interesting parts of the application. I'm also using FFmpeg for taking the screenshots. Now if you've ever used the FFmpeg CLI, you know that that's kind of weird and unwieldy. The C API is worse. So I will go through that as well. But let's start with what's kind of in a WinUI3 application. So when you generate like the default template, you get a bunch of files that you might not know what to do with. The basic idea is that your UI elements are defined in these XAML files. So you have like app.xaml in this. It's an XML based language for layouting and UI elements and styling and things like that. I believe that in the future there'll be nice, like visual designers and things like that. Right now it's an XML, UEdit XML. It does have things like completion for UI elements, but mostly you're editing XML. Okay, so this is my main window. I'll open that up again just so you can see what we had. So like we had up at the top, we've got a toolbar, which has a bunch of elements, a couple of buttons, a slider. If I slide this, then this thing updates. And then this is going to be like my main image I'm looking at, and then these are going to be my thumbnails. So that's what my application kind of looks like. And you can see it defined here. So this is my grid. I can specify, heights and widths, whatever you would normally do in like a grid layout system. And then you can composite other layouting systems. So I've got like a stack panel, which has my, you can see this is my open video button, and it uses some MDL glyph, which is this video symbol. The save icon, there's something built in for that. I can just say save, and it works. It gives me the little floppy disk. Do people even know what floppy disks are now? If someone who is under the age of 20 looks at this, yeah. Anyway, then I have my slider, and then this interesting thing. So I noted that when I do this thing updates, I didn't have to write any code to do that. I just have this text block and I bind it to the value of the slider here, and so that generates all the code to do this for me. So when you have kind of UI elements which are referencing each other, then you can do things like binding the values in order to to get the UI to update without having to write any like C++ or C# or anything. And then I've got my main big image I called main shot. I've got this little border separator, and then my thumbnails down at the bottom, which is going to be my shot bar grid. So that's kind of how you do the layouting. Of course, it will be nice to have a visual designer here, and people are working on it. Some folks who do work on WinUI3 said that they would hopefully make this stream to answer questions that I won't be able to. So if you do have any questions, hopefully folks will be around. They're all in Pacific time, so I'm making it a bit difficult for them. But all right. So when we have our XAML, which defines our UI, and then we have this idle file, IDL, interface description language. This is a Windows runtime thing. So when we talk about the Windows runtime, what we're talking about is WinRT. So the thing about WinRT is that it's not, you want to be able to program this thing from a variety of languages which all interoperate. So you want to be able to write components in C++ and then have some C# code which uses them and interacts with them, and maybe some JavaScript which bridges that. And you don't want to be like writing all of these bindings by hand and like translating APIs and types between C++ and C# and doing all the binary handling and data marshalling and everything that comes with doing like complex language interop for large-scale applications. So the Windows runtime has projections for a bunch of different languages. So you have the Windows runtime, which sits underneath everything, and then there's projections for C++, which is C++ WinRT, Rust, JavaScript, C#, more kind of managed languages. And you want to be able to interrupt all of these things. So that's what this is. It's a description of the elements in my class, such that this thing could then be run. I could modify this thing from some C# code or some Rust code, and I wouldn't have to do any translation of the data. I got a question: does WinUI work well with system themes? Does it require much code for us to have it switch light and dark if the user changed their theme? So I think that's all handled in, for example, we've got that XAML, and you can specify styling in here. So I have done things like change the, I don't think I do it in this application, but you can like style them, and I would imagine that you can try and match system themes. I haven't tried it. Would be interesting to find out exactly how to do that. To see if there's anything obvious. Dark theme updates. Yeah, there's a themes folder, changing theme programmatically. So there's facilities for doing things like that. I don't know how easy it would be to match like system themes, but yeah. It's supposed to be for giving you like a native look and user experience and unifying the UI styles. So that's definitely kind of a goal. Right. So we're talking about IDL. So so this defines what our class looks like and how we can interact with it. Currently, the user experience in Visual Studio for this leaves quite a lot to be desired. Right now it's plain text. I don't get any like auto-completion or anything. There's a lot of work to be done here, and we know that there's work to be done here. So this is not the finished product. Like I said, WinUI3 just came out of preview. Project Reunification just released 0.5. So these things are still early. There's a lot of work to be done, but people are looking into these things. Hey, Oliver. So that's the kind of XAML and IDL. So this is your interacting with the Windows runtime and specifying your WinUI layout. So if we look at this header, you'll notice a few things. One, we get this like WinRT shots reunion implementation thing. So a lot of code gets generated. In fact, if I think this is a generated file. Yeah, warning, do not edit this file. It was generated by C++ WinRT. So C++ WinRT generates a bunch of code based on like our idle file and things like that, which handles a bunch of the data marshalling and telling the Windows runtime what our types are called and how to create them and all of that stuff. So you don't have to do any of that, and you shouldn't really worry too much about what's going on here, as long as everything works fine, right? So yeah, you get some kind of like weird namespaces and types that you don't necessarily need to care about, but most of this stuff is hidden from you. Another thing you'll notice is there's a lot of namespaces. There's namespaces everywhere. So we got like WinRT, Windows Foundation, iInspectable, and WinRT, Windows Foundation, iSync action. You'll want to sprinkle like using declarations around when you're not in a header file. Don't do that in header files. It's bad. But this is the kind of way that you define callbacks. So in our save shots, or let's do open video first. So when we have our open video button, and when we click that, we want some action to fire, right? We want like a dialog box to open, which lets us pick some video file on our hard disk. So that's done by, in here, we specify the on click, then we want to call this open video function, and then that is defined in here. And it takes something which tells you about the sender, and it tells you about any additional arguments. Hey Claim, so far I've just talked a bit about WinRT and WinUI, and shown how the layout is all specified for WinUI, which is in this XML language, and how it interfaces with the Windows runtime, which is through this definition file. So now we're looking at how to make callbacks. So this is our open video function. Right now, I've just said to do, and that's what we'll do now. So, like I said, I've written all this code before, so I'm just gonna kind of bring you along with the kind of things you have to do. So, like I said, we have namespaces everywhere. So I'm just gonna say using namespace, Windows storage. Now the first thing that we want to do when we hit open video, we want to select a video, right? And there's something for that in file pickers. So I have a file open picker, which I'll just call picker. And then I need to do a little bit of magic stuff. So, like I said, previously you'd have to use like, you'd have to target UWP or something like that for these native style modern UIs. Whereas now we're not targeting UWP, we're a native Win32 application. And that has some implications. If I go and have a look at, what's this thing called? I initialize with window. There's a blog post from Raymond. Yes, this is it. From Raymond Chen, which talks about exactly this thing. So say I have a file open picker. I want to pick a file. If I just pick a file, then I'm gonna crash because I'm looking for the runtime's gonna look for a core window instance, which is a UWP thing, and we're on desktop. We don't have a core window, so the workaround for that is to use this picker.as I initialize with window and give it our window handle. What did I call this? Yep, get window handle. And give it a handle to the Win32 window. This thing just calls some com API. I don't understand com at all. I just found someone on the internet who told me what to do and it worked. So this is what you do. You don't have to understand it. I certainly don't. But yeah, basically it's just reaching into the operating system to get our native window handle. You've been doing com. Interesting. Yeah. Where were we? Okay, we're up here. So we've got our window, and then we can start picking our files. So the first thing we want to do is, when you pick a file on Windows, it suggests like you want text files or you want PNG files or something like that. Well, we can do the same thing here. We could say we want to pick MKV files and maybe, MP4s as well, maybe AVIs. There's probably a way that you can specify all of this at once. I'm not sure where it is though. Thanks to Felix. So this tells the operating system Windows, these are the file types we want, and then we can also say that we want to start off in your video folder. So you have a videos folder on Windows. Well, we can get that. It's picker location ID videos library. There we go. Cool. Thanks to fellow Chloe. Right, so now we're starting to get into some interesting stuff. So if I say I want to pick a file, right? I want to pick a single file. What do we get from this? So if I hover over file, come on. IntelliSense, don't fail me. Anyway, this is going to return not a storage file, which is what we really want. We don't. This is going to return a async action, which is basically when we pick a single file, this is going to take some time, right? This is an asynchronous action. So anything which takes over, I think they say like 50 milliseconds in the Windows runtime is defined as an asynchronous operation. So this can happen in the background and you don't have to block. So if we could do something like this. This is our file async, and we could do like file async dot get, and this would block until our operation is complete. But that's bad because we're currently on the UI thread. So if we do this, we pick a file and we call get, the whole UI is going to be locked up. So that's really bad. You don't want to do this. Now, one way you could change that is by like using futures and things like that. But a much better way, which is very nicely supported here, is to use C++20 coroutines. So, if you're not familiar with coroutines, what this says is, I want to call pick single file async. I want to suspend this function. I'm going to stop what it's doing, save where we are, and return back to our calling function, which is, this is a callback from a button press. So our caller function is somewhere like inside the runtime of WinUI. And now, when the user does pick a file, and everything is processed, then the WinUI runtime is going to continue, and we're going to end up here. So this is a coroutine. It'll be suspended at this point, and then it'll be later resumed at this point when we have got our file, which is really nice. Hey, thanks for joining all the way from China. I'm in Scotland. It's wet, always. Cool. So now we don't have a file async. We actually have a file. We have a storage file, which is the type of this. I don't know why IntelliSense is playing up, but these async functions are eager. Yes. So when we call this and co-await on it, it will run on some background thread. And yes, iasync action. Well, so iasync action is an asynchronous action which is not associated with a return object. I think the type for file for pick single file async, if IntelliSense would help me, is Windows Foundation iasync operation, which is templated. So it looks something like this. It's an operation which returns a storage file. So yeah, this will be eagerly run off in the background, and I will be suspended back to caller. Okay, so now we've got our file. Let's say if the user didn't pick a file, then we can, this is an error. We could really handle this, but we're just going to return. Okay, so now we've got our file that we want to take a shot of. I can go and show you the FFmpeg nonsense, which I did. So I made this thing called Shot Taker. It's a pretty simple interface. The idea is you give it a file name, which is a video file, and then you can call take shots with some number of shots you want, and it will take those screenshots of at random points in the video, and then save them all out to temporary files. Then it will give you a collection of the file names. Hstring in WinRT is just the string type which is used internally. Okay, so I can show you the implementation of this. Now, like I said, this is using FFmpeg CAPI, which some parts are kind of nicely documented, other parts are really, really terribly documented, and it took a long time to get this working, even though I'm doing like reasonably simple stuff here. But I think this is interesting, so I'm going to talk about it. So if you aren't familiar with how video encoding works, basically a file contains a number of streams. Those could be audio streams or video streams or subtitle streams. You could have multiple video streams and multiple audio streams all in a single file. And they will be encoded with some codec, which is basically a way of compressing down, because you could think of a video as like a huge 3D array where every 2D slice is a single frame and all the pixel values for that frame, and then all of the frames are the third dimension. But that would be like a massive waste of space because most videos, most of the pixels don't change a whole lot, so they're compressed by looking at the difference between adjacent frames. So how we do this in FFmpeg is, we open the file, we find some information about the stream, we find the best stream, which is the stream we probably care about for taking screenshots of. There could be a bunch of errors, you can't find the decoder, you can't find the video stream, it's fine. Then we need to do a bunch of initialization. So we want to we want to decode from whatever codec the video is stored in, which could be MPEG 2 or like H.264 or I don't know, DivX, whatever. And we want to initialize an encoder where, in this case, we want to encode to PNG. And also we want to do some color space conversions because PNG supports RGB color spaces, whereas things like H.264 use YUV, so we would need to convert between color spaces, which is a whole thing I don't particularly want to explain, but you can look into color space conversions if you're interested in that. So this stuff is not very interesting. You're just setting up a decoder, setting up an encoder, saying that we want a PNG encoder, and we want to use RGB, taking the width and the height of the video, and then setting the frame rate from the video. Then this is our color space conversion, making sure that we encode to RGB 24. Cool. So once we've all done that setup, then we can do the taking the shots. So I want to take random screenshots at roughly even time points in the stream. So say we want to take 6 screenshots. We don't want to take like 6 screenshots right from the start or 6 random screenshots. We want them to be like fairly evenly distributed so that we get a decent picture of what's in the video, say. So I just do a little bit of maths to do that, like work out a step based on the number of screenshots you have to evenly partition the video duration by that number of steps. And then I do some maths to calculate a random timestamp like within those sections. And then this is the bit which took me so long to get working in FFmpeg because the documentation is really, really not great. You need to like do some rescaling of timestamps because timestamps in videos and audio, it's not necessarily an absolute thing. It's relative to like the time base of the encoder and things like that. So you have to do some rescaling. Then we want to seek to that location and flush any buffers we had. This is like the decoder is going to have a bunch of buffers sitting around which are processing data, so we need to flush those whenever we seek around the video. Then we encode our next frame as a PNG and write that back and then just loop around here. I'll quickly show you what the frame encoding looks like. Basically, you decode the frame from H.264 or whatever, we convert it to RGB, and then we encode it to PNG. And that's all done with even more low-level systems. So like with the FFmpeg CLI, you can control what your codecs are and your codec parameters and things like that. This is even more low-level where you're allocating packets to send between the encoder and the decoder yourself, and it essentially gives you like full control over when things are sent to the encoder and to the decoder and allocated and deallocated. So it's for use in like really high you can make like really high performance tools using this. It's kind of nasty. But yeah, this is the FFmpeg stuff that I got working. I think it's a lot easier to understand than all of the samples I found online. There's some examples of how to do like decoding and then encoding to something else, but they're not very clearly written. Like, this makes sense to me. I decode a frame, I convert it, I encode it. I encode it by doing this stuff. This makes a lot more sense to me. But anyway, I don't want to go through like the absolute depths of FFmpeg, but this is the interface, and that's broadly how the video encoding works. If you have any other questions about them, feel free to ask. So now if we go back here, then we can start taking our screenshots. So we can say that the number of shots we want to take is our shot slider. Just remember that thing that we could move back and forth. We're just going to get the value of the shot slider. And that'll be the number of shots we want to take. Then I have a shot taker instance inside this main window class, which is shot taker underscore, and that's a std optional shot taker. So we're going to create a new shot taker from our file name, which we get from here. So toString file.path. Oops. So this will just create a new shot taker here using the file name that the user picked. Then we can say shot taker take shots and shots, and that will give us back a vector of file names, which we can store. I made a vector of file names already inside main window, which is just temp file paths right here. Where were we? Here. Okay, so this is the second interesting thing, or another interesting thing I want to talk about. This could take some time, right? Like, we're seeking around in videos, we're taking a bunch of screenshots. Depending on the codec which is being used, if this is like H.265 or something, which doesn't have hardware encoding in most places, then we'd have to do software decoding. If we're taking a bunch of screenshots, this could take some time. This is like compute bound work, and also bound to the reading the file from the disk. So we don't want to do this on the UI thread. It's a similar problem to what we had here, but where this pick file async, this is written as a coroutine. This is written such that you can easily co-await on it and it will go off and run in the background. But our shot taker is not written like that. It's just written. Can I show how it works now when the job's done by the UI thread? I think for the sample video which I have is just a H.264, so it's hardware decoded and super fast, so it will be almost instantaneous and it won't block anything. But you could get a video which would take a lot longer. I can try it. Where we shot taker take shots. It's not going to be displaying anything yet either. I'll work something out to show the difference once we've done a bit more work. But yeah, so this could take some time. We don't want to block the UI thread when we're doing it, and we also don't have shot taker written as a coroutine so that we can just co-await on it. So what C++ WinRT gives us is a way to switch threads within our coroutine. And we do that like this. So the first thing we do is we want to capture the thread we're currently running on, which is the UI thread. We're currently on the UI thread because this was a callback from pressing the open video button. So this is called an apartment context. I don't know why it's called an apartment context. I don't know if this is some something in the literature where apartment has a sensible meaning here, but this is what it's called. So it's an RAII object essentially. So this captures the current thread we're running when we construct it. We don't have to give it anything. It just works out from context. Then the next thing we do is we want to resume on the background thread. So what this will do is it returns a coroutine. It returns a coroutine object which we can co-await on. When we co-await on it, this function will get suspended and control flow will pass back to the caller. Then the runtime will schedule the rest of this function on a background thread. So this is kind of cool. I like this a lot. We're switching thread in the middle of a function. And then when we're done with this, we want to get back to the UI thread because we want to show what we got to the user, right? And you can do that by co-awaiting on the UI thread. Right, we captured this earlier. We just co-await on it, and we're currently running on a background thread. When we co-await this, we get resumed back to the runtime system, and the runtime system gets told that we want to resume on the UI thread. So then later on, the scheduler is going to reschedule the rest of this function onto the UI thread. Thanks to follow Jess Scarlett. Does that make sense? Is there anything else you want me to explain about that? Because it's this kind of model was new to me when I first saw it, and I think it's really cool, but it can blow your mind a little bit because we're switching threads forward and back using a scheduler which is all running on this single function. I mean, it's not a function, it's a coroutine, but you know what I mean. So that's how if we have some compute-bound work or some long-running work which isn't implemented as a coroutine, we can run it on a background thread and then resume back on the UI thread. Cool. So once we've done that, we can populate the UI images, which is something that I wrote already because it's doing a bunch of GUI stuff which is not interesting. I'm just creating a bunch of layouts and appending UI elements and setting their heights and things like that. This stuff is not interesting. This thing is kind of interesting. This is when in fact, I'll run this so I can show you. Is there some default thread pool in WinRT? It's using the Windows thread pool, the operating system thread pool. Which is good because it means that it's collaborating quite closely with the operating system. So go and run this and see if we get a failure anywhere. It's taking a while to build because you see these WinMD. That's the file format which is used for expressing metadata for the Windows runtime. So this is like, it has to do a bunch of additional processing as part of the build. That's fine, I get a bunch of warnings, it's fine. You should listen to your warnings. Don't do as I do as I say. Okay, this looks like it's trying to run. I'm building in debug, so it's got a bunch of simple things to load. Okay, so now if we open a video, we get a file picker, and I can pick a file. And oh, there we go. Oh, that actually did take a little bit of time. But it worked. We got a bunch of files. We can click on them. We can zoom in and out. This is from a experimental film that I really like. You can download on Vimeo. But yeah, it worked. And one thing to note is that the thing I wanted to say back here is when we have our thumbnails, yeah, like you could pop up a loading symbol or something here. When I mouse over this, then the little refresh button appears to reload it. And that's done just by, I can use a C++ lambda. So I say when the pointer enters this thing, then call this lambda as a callback. So you don't have to, define a whole function on your main window class. You can just send it a lambda, and it will call it when the pointer's entered. And there's it's a UI framework. There's a ton of different callbacks you can have to essentially anything. So yeah, that seemed to work. I wonder what does happen if we... You're asking what happens if we just do this on the UI thread. So if we do that... So now this code is running on the UI thread. Like I said, if you had, a loading symbol, which was running on the UI thread, then if you did this, then that would just hang, I think. Right now, I think the only difference will be that we won't be able to click any of our buttons. I'm not sure what will happen. I haven't tried this. Building. There we go. Loading symbols. Okay. So if we hit open and we open, then yeah, we can't move our, oh yeah. Not good. Yeah, I'm not sure what that error is, but you could see that we couldn't move the slider or anything like that while all the code in the background was running. So it's locked up the UI. So if you have a more complex UI that you still want to be doing things while you're loading stuff in the background, then you don't want that. So we want to do this. Yeah, thanks to Full Hadmer. Right, another problem is, a bunch of this stuff could fail. We could get an exception from almost anywhere, depending on how we've written stuff. But, the C++ WinRT uses exceptions a lot. So if something here fails, like this initialization or populating the UI images, anything like that, if that fails, then we're going to get an error, which we probably want to report back to the user. So we could do something like, let's just say we want to, if any error happens in this block, then we want to report it back to the user. One thing we could do is have an optional string, which is an error, and if we catch a runtime error, the lack of async RAII sometimes makes you sad. Yeah, I haven't really thought too much about that. If we get a runtime error here, then we can capture it, say that the error is e.wat, because we're going to be doing more co-awaiting and you can't co-await inside a catch block. Then later, if we get an error, then you want to display it back to the user. So you can do something like controls, create a content dialog, and then you can do anything here like sets title, so this is something you need to think about when using C++ WinRT as well, is boxing values, because anything which is going into the WinRT world has to be accessible from any of the languages which there are projections for, you have to box a load of stuff, you know, which is essentially just dynamically allocating it in some known location. So you have to box your my title here. I could, you know, present this error string which we get back to the user saying that our we're going to create H string from our error string and display that to the user. And then we also need to hook this into our UI, which you do using XAML root. So we just get the XAML root from our shot slider, like that. And then we show it by collating on error dialog dot show async. And that will show our why is this not working? There we go. That'll show our error dialog to the user. So now, here's something really subtle that took me a lot of time to debug. What happens if this call throws? So, inside this block here, between resume background and collate UI thread, we're running on a background thread, right? If this throws, we end up in this catch handler. We have not collated on the UI thread, so we're still running on a background thread. And then we come in here, we try to create an error dialog, get a bunch of UI elements and show something on the UI, but we're not on the UI thread. So this crashes. And it's very difficult to reason about. So, you know, a fix is to put another try catch around here and, you know, make sure that you're catching a runtime error E and storing it here. So now if it throws, then we end up in this catch handler. We exit the handler, and then we collate on the UI thread, and then we can display back to the user. So yeah, this is something you have to be aware about if you're doing a bunch of switching. You have a bunch of you know, things which could throw exceptions. You have to be really, really aware of what's going on. So yeah, that's most of what I wanted to show today. That's the open video. Now we want to save it, don't we? So it's going to be broadly similar. Where's save? Here we go. So it's going to be, when we hit the save button, we probably want to pick a folder to save in. So we're going to do something very similar to the file picker, which we used earlier. So we say pickers, folder picker. And then we did the whole picker.as I initialize with window, dance, initialize it with our native window handle. Cool. And then our file type filter for this one, because this is for saving, is just going to be L.png. You need L everywhere on these string literals because, you know, the history of Unicode on Windows and how it's not great, and how we need to use wide strings for interfacing with the operating system. So when you're using C++ WinRT, make sure you use wide strings on the boundaries. We'd recommend using UTF-8 internally if you can, but on the boundaries of interacting with the operating system and the Windows runtime, then you need to use wide strings. Would it work if the file name contains emoji? I guess so. Like, I would maybe need to change some project settings, but it might work. There'll be ways to make it work. But yeah, I haven't done a ton of Unicode stuff with Windows because it kind of terrifies me. Yeah, some dropped UTF-8 everywhere in chat. Would recommend having a look at that. We can say that the suggested start location for this one is picker location ID pictures. What in IntelliSense? This is called pictures library. Do not have the include for this or something? Is that why IntelliSense isn't liking me today? Yeah, if only we had some kind of time machine, go back and change. Doesn't have a suggest start location. Suggest ed start location. There we go. Okay, and then we can say our folder is co-await picker.pick single folder async. So this does, broadly the same thing as the picking a file, but it picks a folder instead. And then we can say if we don't have a folder, the user hit exit or something, then return. Okay, so now we want to, taking the shots produced a bunch of temporary files, and we now have them in our object. So we want to save those to disk somewhere. I'm going to cheat here, copy paste some code that I had, because I don't like doing date time. But yeah, this is a way to get a date timestamp. We're just getting the time right now, and then formatting it with your month, day, hour, minute, second. So this will give us a bunch of time-stamped files, and then we want to save this to disk somewhere. So we'll say this would be nicer if I had an enumerate range, but C++20 ranges didn't get enumerate, which is frustrating. Maybe for my next stream I should write an enumerate range. I think that would be interesting. Maybe could even write an enumerate range with my generator thing that I wrote last week. Okay, so then we say for each of those file paths, each of the temporary files which we created, then storage file. We're going to get a file handle from a path. Oops, not patch, path. And then from that, we want to create a new file name equals hstring, and we'll prefix it with shots, and then add the date time onto the file name. Oops. Add an index, and then .png. That should be our file name. And then we can trigger a copy from our folder to our file name. Sorry, this should be, oh yeah, file.copy async folder file name. So now this will copy our temporary file into a well-named file in a directory of the user's choice. Now hopefully, if we build this, everything will work. While this is building, if you have any other questions about WinUI or C++ WinRT or coroutines, maybe FFmpeg, feel free to ask. As much as I have complained about FFmpeg, I do think it's one of the best pieces of software that I've ever used, just in terms of how powerful it is and how much stuff you can do with it. Okay, so now if we open our video, we'll take a bunch of screenshots, which will be done on a background thread, and then maybe we can retake one of them. We can hit save. We can save to our shots folder, and then if we go to pictures, shots, hey, we got a bunch of screenshots, and they all have nice file names. Can open them in usual just photo viewer, so our PNG encoding works. You can see the thumbnails. Pretty cool. The question: are there synchronous versions of functions like get from file from path? Because yeah, if they were synchronous, then they would block the UI thread. Yeah, so if we were to do this, file.copy async.get, right, this would do a copy. So you're asking about the file picker, but I mean it's the same thing, right? This would do the copy synchronously, which would block the UI thread while the copy is happening, and you don't want to block the UI thread because then everything just hangs, right? Whereas when we do co-await, then this copy is scheduled into the background, the runtime is resumed, so the usual UI event loop is resumed, and that's going on handling other user events. You know, maybe I hit some other button in the UI, I play around with the toolbar a bit while this copy is happening, or while the file picker is opening. I can do that because the UI thread's not blocked. And then when the copy has happened, or when the user has selected a file, then the runtime is going to reschedule this coroutine, and it's going to resume. So it's a way of writing asynchronous code without having to use a bunch of futures with callbacks, because that becomes a nightmare. You know, especially if you have like loops with asynchronous actions inside them. Yeah, like if I have this loop, right? I want to do this a number of times. So if I wanted to say like dot then, if this returned a future which I could schedule a continuation on, right? Which is the usual way you write asynchronous code when you don't have coroutines or some kind of like async await functionality. Then this is the way you would write it. So you could do like dot then and give it a continuation, but how would we write our continuation? Right, we would have to like allocate some state to keep track of which file we're currently looking at, and pass that around. It would be a nightmare. It's horrible. If you go and look at I think Gornishnov has which one is it? Coordination Up has a bunch of talks on coroutines, and there's one example which Gore uses of reading from a TCP socket. And it gets really hairy. Oh, in fact, I think that might be on CPP reference as well. Oh, but the bad version is not. Oh, here we go. Yeah, this is the kind of thing you do. Returning a bunch of nested thens, having to use make shared because you've got some state you need to carry around. Nightmare. Don't do it. If you can get away with it, at least. Alright, not seeing any other questions. Yeah, moving existing Win32 code to C++ WinRT. Yeah, that's good. And part of the whole point to this is we want people to be able to do it iteratively, right? Like you can't, if you have a huge like MFC application or something, that you can't just rewrite the whole thing in WinUI right off the bat. So we want people to be able to like slowly move things over to more modern systems. Thanks for the follow, Arch. Cool. So yeah, we got this all working. We had our WinUI specified in our XAML. We had our WinRT stuff specified in our IDL. We did a bunch of coroutine stuff, which is all scheduled for us. We can switch threads from within the same function and then resume back on the UI thread. And it works modulo things like throwing exceptions. And like I said, there's things which need improved, like the editing of this IDL file, which is a pain, a visual editor for the XAML. But things are getting there. So yeah, if you want to play around with this stuff, what I would suggest is just going onto the Microsoft.docs for WinUI, and there's a get started, which tells you everything you need to do to, start a new project, all the things you need to install. Like there's an extension that you really have to install to get all this working nicely, and then it walks you through, how to create a WinUI3 desktop app, which is exactly what I have here, and how to edit it and everything like that, localizing it. And this is the kind of thing you could like publish on the Windows Store. I haven't tried that. I haven't like tightened this up enough that I could put it on the Windows Store, but no, I could if I wanted to be able to like 1-star me into oblivion for all the bugs and crashes. But yeah, I would highly recommend like going and playing around with this, especially if you play around with it and you have any feedback, either for the folks doing like improving the Visual Studio style stuff, or the folks writing WinUI or C++ WinRT, then feel free to get in touch with me and I can route it to the relevant folks. Thanks to follow 4 bad cats. I only have 3 cats, but they're not bad. They're very good. So yeah, would love to hear all of your feedback and suggestions. But yeah, does anyone have any other questions about any of the stuff that I've talked about? I know there's a bunch of stuff here. Or any ideas for things to do next week. I think unless any other things pop up in my mind, I think I'll do, writing a bunch of different ranges. Like, did Cartesian product didn't make ranges 20 or zip either. So we could try implementing like zip and Cartesian product and enumerate as C++20 ranges and see how we go. I think that would be cool. But yeah, not seeing any other questions, so I think I'll call it there. And thanks for everyone for joining in and for helping me with my mistakes. And yeah, this was fun. I will see you all next week, and hope you have a great day. See you all.